We're still working with quadratic functions, but now we're going to look at the vertical shift form, which is y equals ax squared plus c. So we want to figure out what happens to the graph when c is added to the equation. And we want to graph each of these. So here's our parent function. So again, we're going to have 0, 0. 1 squared is 1. 2 squared is 4. And 3 squared is 9. So then we can graph the symmetrical points. And we have our parabola. So that's our parent function. So now let's see what happens when c is a positive 3. So here if we take 0, so 0 squared is 0, plus 3 is 3. 1 squared is 1, plus 3 is 4. 2 squared is 4, plus 3 is 7. 3 squared is 9, plus 3, which is 12. So then we can get our symmetrical points and graph. Now I'm going to highlight this one yellow so that I know this equation matches this graph. And as we can see, it does the vertical shift, and it shifts it up 3 units. So this one, when we graph, should be shifted down 2 units from our parent function. So if we do 0, 0 squared is 0. 1 squared is 1, and 1 minus 2 is a negative, negative 1. I'm sorry, 0 squared is 0, and 0 minus 2 is a negative 2. So there's our first point. 1 squared is 1, minus 2 is a negative 1. 2 squared is 4, minus 2 is 2. 3 squared is 9, and 9 minus 2 is 7. So now I can get my symmetrical points and connect my parabola. I'm going to highlight so I know that that parabola matches that equation. So as you can see, based off of that function, we are shifted down 2 units. So what is C? C is the vertical shift on our graph. So now we want to graph each of these 2 functions. So looking at this graph, since a is bigger than 1, this should become more narrow compared to our parent function. This one is going to reflect over the x-axis because it's a negative. It's not going to become any more narrow or wider, but it's also going to shift up 3 units. So let's graph this one first. So let's start with 0. 0 squared is 0, times by 3 is 0. 1 squared is 1 times 3, which is 3. So we're at 1, 3. 2 squared is 4, and 4 times 3 is 12. And then we're going to run out of room. So then I can graph my symmetrical points, which we know they'll match up even though if they're symmetrical, because if we took negative 1 squared is 1, and 1 times 3 is 3. And negative 2 squared is 4, and 4 times 3 is 12. So it became more narrow compared to our parent function, and it didn't move up or down or reflect. So for this one, we said that by the time we're done, it's going to reflect and it's going to have a shift up of 3. So if we take 0, 0 squared is 0, times by negative 1 is 0, plus 3. So we end up at a positive 3. 1 squared is 1, which turns to a negative 1, plus 3, so it's at 2. 2 squared is 4, so it's a negative 4 plus 3 is a negative 1. 3 squared is 9, so negative 9 plus 3 is a negative 6. So then when we do the opposite, it's a negative 1. Negative 1 squared is 1, times by negative 1, so negative 1 plus 3 is 2. A negative 2 is negative 2 squared is 4, so negative 4 plus 3 is a negative 1. And then negative 3 squared is 9, so negative 9 plus 3 is a negative 6. So when we graph those are symmetrical points, then we can connect our parabola. So when we look, it is shifted up 3, and it's also a reflection.